Okay, this is a practice quiz for P2, P3, P5. I'm going to take a moment, write them out, then try to go through as many as I can. Okay, we're going to go through these. I have them written out on the next slide, so let's get going. To write the equation of a line, you need a point and a slope. At number 1, I have 2 points, but I do need the slope, right? The slope is y minus y over x minus x. So we need to plug in some y values. -2 minus -2. Do we have to do this? No. What might you notice? What are both y values? -2. There's your answer. That's the equation of the line. If you did this, you would end up with the slope of 0. But I'd rather, if you recognize both x's are the same, x equals that. If you recognize both y's are the same, y equals that. Now on this other one, you do need to know you find your slope. So again, it's going to be y minus y over x minus x. So choose a y value. Which of these y values? You want to start with 1/2 or 1/4? It doesn't matter as long as you're consistent. 1/2 minus 1/4. If you start with the 1/2, you have to do -2/3 minus 1/3, I believe. I would probably think of 1/2 as 2/4. What's 2/4 minus 1/4? 1/4. -2/3 minus 1/3 is -3/3. So that's 1/4 divided by -1. I believe it makes the slope -1/4. Does anybody agree or disagree? Let me just look at it again. Y minus y, it'd be 2/4 minus 1/4 is 1/4. -2/3 minus 1/3 is, yeah, so the slope is -1/4. We're going to use point slope. Y minus a y value is equal to m times x minus the x value. I found the slope. The slope m was -1/4. All I need now is to decide which point I wish to use. So, I don't care. This one has no negatives. Why don't we use that one? The y value there is 1/4. The x value is 1/3. You could use either of the original points and you should end up with the same answer. I'll ask you to put it in slope-intercept, so we're going to distribute. That's -1/4 x. A negative times a negative is a positive. Top times top is 1. Bottom times bottom, 4 times 3 would be 12. I'm going to add 1/4. 1/4 is the same as 3/12. Is that correct? 3/12. So that's going to cancel, and you're going to get a -1/4 x. 1/12 plus 3/12 would be what? 4/12. Please simplify. That's only 2 instructions I put on every test or quiz, is to show work and simplify. So 4/12, hopefully you know, simplifies to 1/3. Now, I don't want to say it the wrong way, but if the arithmetic is that big of a challenge, when we hit the conceptual parts of the course, it's going to really be difficult. So hopefully the arithmetic is not an issue. 3 says, gives me this, A1F of -1. So I'm going to replace every x with -1. So I put in a -1 and a -1 for every x. So what is f of -1? You have to square it first before you multiply. Be careful, your calculator might tell you otherwise because it's following the strict order of operations. Use parentheses basically if you have to. 2 minus 3, I believe that makes this result -1. Now, if we have f of x equals 2x squared minus 3, and I want you to find f of x plus h, you're going to replace every x with x plus h. At this point in your math career, you should know how to square a binomial. You square the first, square the last, so that's h squared, and then twice the product in the middle. If you multiply these, you get xh. Twice it or double it is 2xh. So you're going to get your answer to be 2x squared plus 4xh plus 2h squared minus 3. And that's what this answer will be. I don't think there's any like terms to combine. Plus 2h squared and minus 3. So that would be the result for part B. Okay, we're on to number 4. This is probably going to be one of the harder ones. We have f of x. We know what f of x is, so why don't we just fill that in? I know h goes on the bottom, so I can fill that in. F of x is 1 over the radical x minus 3. If I replace the x with x plus h, what would I have? If I put in an x plus h, I think I'd have this. So you have 1 over radical x plus h minus 3. At which point I have fractions and fractions, I'm going to multiply by a common denominator. So the common denominator you can always get by just multiplying the two denominators. So it's going to be radical x plus h minus 3 times radical x minus 3. Again, it's going to be over itself because that makes it into a 1. I usually call it a fancy form of 1 because if you multiply by 1, you don't change the value. You're allowed to multiply by 1. When I multiply here, the multiplication division, these two would cancel, leaving me just that radical x minus 3. So when I multiply there, I'm going to get radical x minus 3. Minus, when I multiply here, what's going to cancel? Those. And what's going to be left? That thing, right? So what's going to be left is the radical x plus h minus 3. In the denominator, you have all this stuff. X plus h minus 3, radical x minus 3. Now, I'm going to get rid of the radical in the numerator by multiplying by its conjugate. The conjugate, let me change colors so it's not exactly the same. The conjugate of a minus b is a plus b. So what I'm going to multiply by is the radical. Instead of minus the radical, it's going to be the radical plus the radical. Again, a fancy form of 1. A plus b times a minus b, I really hope you know that that would turn it into a squared minus b squared. That's kind of what's called the difference of squares. And those two are called conjugates. Now be very careful. If this is a, what's a squared? The same thing without the radical. Whenever you subtract, use parentheses. If this is b, what would b squared equal? The same thing without the radical, x plus h minus 3. Now I'm going to leave the bottom, it's all that stuff in the denominator, but let's clean up the numerator. What's x and a negative x? Well, they add to 0. What's a negative 3 and a positive 3 when I distribute this? That's going to make this into a positive 3. So negative 3 and positive 3, I think, also add to 0. So what's the only thing on the numerator when I distribute? There's a negative, though. Negative h, which very conveniently can now cancel with this h in the denominator. That's the whole purpose of using the conjugate. is to simplify it. And this is times radical x minus 3. So those could divide out or cancel, and your final simplified answer would be this. You've been told you cannot leave a radical in the denominator. Like I say, sometimes in math we have to lie to you to bring you to the next level. Now you're allowed. Once you're in calculus, you're allowed to leave radicals in the denominator. So there's a result. Okay, you're exactly correct. The denominator has more than just this. It also contains this, right? So I think my answer is not exactly 100% correct. I do think that was part of the denominator, but I don't have it all. We have radical x plus h. There's more to it than that. X plus h minus 3 times radical x minus 3. But you also have it times its conjugate. So you're right. X minus 3 plus radical x plus h minus 3. I hope that's what it should be, because I neglected to put that one part of the denominator in there. And you're right. If all I wanted was f of x plus h, all you would do is replace the x with x plus h, right? And that would be your answer. That's not really what I wanted. That's a little too simple. But you're right. I should have asked it as this. So what I'd like you to do is change number 4. I'll probably fix it on the recording, hopefully. So 4 should have ended up something like this. Question 5. You're not allowed to divide by 0. What makes the bottom 0? 2. So I look for what makes the denominator 0. Basically, x cannot equal 2. How do I write that in interval notation? Small to large, don't include it. Small to large, don't include the 2. You can never include the infinity. The range, you might have to know what it looks like. This is a vertical asymptote at 2. Because the power on bottom is bigger, you have a horizontal asymptote at 0. And it's going to look like this. What's the only y value it cannot equal? 0. So how would you write that in interval notation? Small to large, don't include 0. Small to large, don't include 0. Now your square root, you can't take the square root of a negative. So you take what's called your radicand, the part under the radical, and you make it positive, or 0. So that means it's going to factor into 2 plus x, 2 minus x. Then you have to do something like we did on that algebraic diagnostic quiz, which I'll also put on Canvas if you want to see the solutions for that, where you had to do a sign analysis. So what makes this 0 is negative 2 and positive 2. That splits the number line into 3 distinct regions. If I put in a negative 3, 2 plus negative 3 is negative. 2 minus negative 3 is positive. What is a negative times a positive? Negative. Between negative 2 and 2, if I put in a 0, 2 plus 0 is positive, 2 minus 0 is positive. Positive times positive yields a positive. So I put positives there. How about if you put in a 3? 2 plus 3 is positive, but what's 2 minus 3? Negative. Positive times negative is negative. I need it greater than or equal to 0, so that would be negative 2 to 2. That is your domain. Okay, to find the range on number 6, the domain is negative 2 to 2. It includes the endpoints because you can take the square root of 0. Now, if it was 1 over that, you couldn't use the endpoints because it would cause division by 0. Now, if I just plug and chug, make XY table, and I put in, let's say, a negative 2, a 0, and a 2, what would I have? If you want to put in more, you can. These would give you 0. If you put in a 0, what's 4 minus 0? 4, and the square root of 4 is 2. So it ends up looking like this. You're only going negative 2 to 2, and it's going to go through that point, and 0, 2, right? So it's looking like this, which means the range would be 0 to 2. If you wish to write it in inequality, that's fine. It does actually equal those, so I can use inclusive, and that would be the range. Now, I'm just going to show you, isn't this y equals the square root of this? Can you square both sides? What happens if you add x squared? If you add x squared, you'd have x squared plus y squared equals 4. That means that's a circle centered at the origin, radius 2, right? However, the square root is only the positive part. That's why we only have this part of the graph. We don't have this bottom part. So that's how I ended up with this thing down here. Okay, we're going to move on to 7. Yeah, we want to solve for x in 7, 8, and 9. So I have 4 to the x equals 64. 4 is a power of 2. 2 to the second. And it's 2 to the second to the x. That means you power to a power, you multiply your exponents. 64 is also a power of 2. 2 to the fourth is 16, 2 to the fifth is 32, so this would be 2 to the sixth. The bases are equal, the expressions are equal, therefore the exponents must be equal. You divide by 2 and you get your result for number 7. You could do these with 4 to the negative 1, because 4 to the negative 1 is 1/4. You could also break it into 2's. And so power to power, you multiply exponents. 16 is 4 to the second. So if the bases are equal, expressions are equal, you know that the exponents have to be equal. And that makes x a negative 2. Number 9, to solve for x, we have to get rid of the e. So how do you get rid of an e? You do the inverse function, the natural log. Natural log and e usually will eliminate each other, and you'll end up with your answer of x equals 3. If you want to do it properly, you apply the properties, pull the x out front, realize that the natural log of, sorry, it's not 3, it's natural log of 3, right? You pull the x out front, realize that natural log of e is 1. So the answer really is natural log of 3. On to number 10. We want to expand and condense these logarithms. There are properties of logarithms. So if I knew that the log of a times b is log a plus log b, log of a divided by b is equal to log a minus log b, and log of a to the b power allows you to pull the exponent out front, giving me b natural log of a. These are what are called the properties of logarithms, or log properties. We're going to use these on these two questions. Okay, this is a log of a quotient. I believe it is this one in the middle. So I'm going to do log x the top minus log of the bottom. Now what did I do? I did the natural log of a over b, and I called it log a minus log b. Again, this middle formula. The only thing I'm going to do, I'm sorry, that's a square root, right? Yeah. That should be a square root here. Now, I'm going to rewrite the square root as a 1/2 power. The square root is a 1/2 power, a third root is a 1/3 power, fourth root is a 1/4 power. This last property allows me to pull the exponent out front. So I'm going to do that right now and do 2 natural log of x minus 1/2 natural log of x plus 2. And that is, I believe, the answer at this point. I don't think I can apply any more properties. On 11, we have subtraction of logs. Is that this thing? Log A minus log B? So I'm going to convert it to the other side, which is going to be what? Log of division. So it's that one, and I still have minus this. Do you agree? Okay, now I have another subtraction. What do I do? Divide. So the question is, how do I divide x over x minus 1? And then I want to divide it by this, right? X plus 1. So you want to divide it by x plus 1. Is that correct?
Isn't that x minus? Oh, wait, no.
I believe, oh, they are. This first one's a plus, and the second one's a minus. Lost a couple signs there. That's a minus, a 1, right? So that's a plus 1, and this other one, the second one that I'm dividing by, is x minus 1. Do you know stay, change, flip? If you're dividing by a fraction, that stays, the operation changes, and you flip it. So what does that become? Is that x over x squared minus 1? So you're going to have x over x squared minus 1. Now I have the 2 in front of it, just like here. Could it go up as the exponent? So you're going to have something like this. There's different ways of writing it, but I believe that's probably the most common way right there. Perhaps it would have been more direct to do an 11 this way. Can I factor a negative out of both of these? If I take a negative out of this and this, isn't it going to change the signs? So what's it going to become? Natural log of x plus 1 plus natural log of x minus 1. Now, you have natural log of x minus, these are added, so that means you multiply them. Does anybody know x plus 1 times x minus 1? Difference of squares? X squared minus 1. Now these are divided. So what do I do if they're divided? I'm sorry, subtraction. Subtraction turns it into division, right? So you have the x divided by x squared minus 1. Finally, put the 2 up as the exponent. Is this the same result I got the other method? So I don't know, whichever way you see clearer.